Question 4, example 4, we have 64x squared y minus 4y. I have here front and center. Ask yourselves, is there a GCF that can be factored out? If so, let's do it. So we do have a GCF that can be factored out, and that GCF is what? It is y. So we're going to factor out, it's not just y, but it's a 4 and a y. Because we can factor out a 4 from the 64, and we can divide out a 4 from the 4 as well as take out the y's. So we're going to factor out a 4 and a y. And as we factor out the 4y, divide that out, we're going to have 16x squared minus 1. Then we have two terms. Both terms are perfect squares, perfect square. Then we have a minus sign, so we can factor the 16x squared minus 1. Opposite signs. Break down 16x squared. We have 4x, 4x. Break down 1 for the last terms. We have 1 and 1. And don't forget about the 4y that was factored out at the beginning. And that's our answer. 4y times 4x plus 1 times 4x minus 1. Example 5. We have v to the fourth minus 625. Let's put an asterisk next to this question because this is going to be a multi-step question. One reason, because we have a power of 4. If you looked at the other examples, as we factored, the highest power was 2. So because this exponent of 4 is a multiple of 2, we can factor this binomial because we can find two identical factors that would give you v to the fourth, and we can find two identical factors that would give us 625. So let's set up the template. Two terms, both terms are perfect squares. We have a minus sign, so it's factorable. So we're going to place our opposite signs in the parentheses. And then let's break down the first term. What times what would give us v to the fourth power? That will be v squared and v squared. And then let's break down 625. What two identical factors that would give us 625? That is 25 and 25. Now, so this is our answer, part of it, okay? But what I do want to say is sometimes the factoring process, the steps, the guide, you may have to start over because you have to look at your factors and you have to say, well, can I do anything else to these factors? Can any of these factors be factored again? Now remember, there were 3 rules that must take place whenever we identify a perfect square binomial. There must be 2 terms. Okay, well, we have 2 terms in each of the parentheses here. Both terms must be perfect squares. Well, look at each parenthesis. Both terms, well, I won't say both terms. Well, both terms are perfect squares. Okay? We can find 2 identical factors that would give us v squared. We can find 2 identical factors that would give us 25. But where I told you to place an asterisk here, there must be a minus sign. In order for us to factor a perfect square binomial, look at the key word to this. It says difference. There must be a minus sign. So as we look at these 2 parentheses, one of these can be factored one more time. And the one that's going to be factored is the one with the minus sign. The v squared plus 25, we can't do anything to that because remember, when we go back in FOIL, our goal is to have the middle terms cancel out. So we're going to factor the v squared minus 25. And then set up your template, place your opposite signs in the parenthesis, and let's break down. I'm going to cover up this v squared plus 25 for a second, and let's plug in the appropriate factors to the appropriate places here. So break down v squared, we have v and v. Break down 25, we have 5 and 5. Okay, so as we look at these two factors, I'll look to see if they can be factored again. And no, it cannot be one because both terms are not perfect squares. Okay, so we can't do anything to the v plus 5, v minus 5. But as we write our final answer, bring down the v squared plus 25 because that was part of the factoring process. So this is our final answer, v squared plus 25 times v plus 5 times v minus 5. I will say there is no such thing as a sum, okay, a sum of two squares. There's only a difference of two squares. We definitely will talk about why in class why there is no sum of two squares. I'll rather focus that on in class when I see you next. So, but difference, there must be a minus sign in order for the binomial to be factored.